most of you.
Take one.
Most of you are finally doing it. It should say title. Then they should actually be.
I did put a title.
I did, and you had some marked on it. You had to put the title and that on it.
Whoa.
And
You
of
just put
course,
title, semicolon. Semicolon. Absolutely, okay. No, I didn't have to.
I just put it.
Well, my conclusion.
all right. These sections in your lab should be very easy to find. Now, so you know, the markups on your lab are really not, well, they are kind of for you, but they're more for me than for you. Now remember, I read 20 different labs, and there's often 20 different reasons that you got points taken off. So you need to come and see me to make sure that we're on the same page, because we want to be able to write a good scientific paper. All right, so these sections are what I'm looking for. And so you know, each section is worth 18 points. Your polyatomic ions will then cover the rest of that. So you need to make sure that we have those things in there. Now with the last lab that we did do a title and we did do a purpose, and we had those things in class. But the procedure, some of you tried to rewrite a procedure. If I could actually do the lab by following your procedure, then you got full credit. But others of you, I could not, you cannot do the lab with the procedure you gave. But I didn't understand this one, because I did say, if you actually, Red, head up, if you actually were given a sheet with the procedure on it, why would you retype the procedure? Why wouldn't you just say C sheet?
It was.
Oh.
The background audio.
I mean, that's what I would do.
I feel like you would call us out for that.
No.
And you'd be like, you can't do that.
In fact, if we review the procedures on the sheet, and I did mention you could just say C sheet. Now, we can't always C sheet for everything, but for instance, for the one we did on Monday, you guys are not going to be able to C sheet it.
I copied the sheet down word for word, and I still got 12 points off.
You're a special.
Well, it was, it was like phrase for phrase. It was more like the message translation.
No, this is nowhere close to the message. It was 2 pages of procedure on the sheet.
Right, but
You
like,
whittled
it's
that
not
down
word
to
for
6,
word.
not even complete sentences.
It was phrase for phrase. Sentence for.
Dry overnight.
Hey,
I mean, how else do I say that?
That is technically what we did.
Mr. Lesniak,
Put it in
Yeah.
the beaker and let it sit
hypothetically,
overnight.
could we say, as the procedure, C sheet for final results?
What he said.
Feedback of sheet. Oh my God.
So that would probably only work in the procedure, or if you were handed out and you had some really good graphs, but you would also have to hand in your paper too. So if you don't hand in your paper and you say C sheet, then there will be nothing to correlate it to. So in other words, if you do have data and observations, you have graphs that you're done, they usually are, it will say figure 1, figure 2, and you can just put that down. See figure 1, see figure 2. In fact, when you read scientific papers and they refer to graphs, it'll say, it'll do some explanation, it'll say refer to figure 1.2. And you can find figure 1.2 somewhere in the report, and then you can look at it. Now, that's when you're given worksheets and stuff like that. Now, in our latest lab, we weren't done. That did not take place. In other words, this was a lab that we created in the classroom in order to find, hopefully try to find the identity of this, or to try to prove that it's one thing or another thing. Magnetite or not, or does it even have magnetite in it? I've done some investigating over the last day or so, and I have this whittled down to actually 2 things. So I believe it could just be a rock with some magnetite in it. But I don't think so, because the densities are not, even though 6 and 4, that's enough where it's probably something different. But this density right around 4, just below 4, can give you some hints. And remember, you can get some, I already said you can get some extra credit if you go and try to investigate what you believe this rock is. We know it's magnetic. We know it has a density of somewhere around 3.9.
It's neodymium.
So, I do have it narrowed down to what I believe it is. And we'll see what results we do get from you guys. Anyway, let's continue. For this one, you guys can figure out a title very easily. For this one, the purpose has to be something in this manner. All right? We're using a calorimeter and calorimetry to try to determine the identity of an unknown rock, mineral, or whatever you want to call it. And we also measured the density of this unknown rock to help in identification. So, that helped us. We're going to have major clues in the end to help us identify this rock. And there are 3 major clues that we got to have. Major clue number 1, it's magnetic. That's pretty important. And it's decently magnetic too. We saw that just a normal, this is not a strong magnet, and yet that's a pretty strong attraction. So this rock is decently magnetic. It's got a good amount of iron and nickel in it for sure. All right, 2. We have a density. And it was a measured density of around 3.9 grams per milliliter. And 3, did someone go home and finally calculate the specific heat capacity?
I was just pull my notebook. Hold on.
Give it 6, 7. 6, 7.
Wait, what is that said? CR.
C of this rock was?
Oh.
I think I got 0.83 joules over grams times degrees Celsius.
Point what again?
0.83.
I think that's right.
2 stick digs, 1600 over 26.85 times 72.
So let's go through that. Let's go through that math real quick. Because here's one thing I want to show you guys. Oh, and this brings me to another sad but true point.
Another one?
Oh, that's a beautiful place.
The notebook LM, which is immensely useful, is only growing with knowledge as we put more and more of these videos in. I did find an issue. So I was looking on, it was Mac's computer. He didn't do anything.
Yeah.
But when I looked at the computer, I did not see the beautiful and lovely, and they are. Like, you guys are going to be like, dang, I wish I had that. Well, some of you. Others of you will be like, whatever. But I hope you say, dang, I wish I had that. Because what? See, these are, I continue to work in Notebook LM quite a bit to see what its capabilities are and its capacities are. And for instance, I made this for you.
We need that.
Bring it over.
Oh, that's tiny.
Wow. I think he's God.
Man, I wish I had that.
Oh my god.
Oh, yeah. That's the thing it is setting for this.
Do I need to
This
turn it?
is an infographic that actually just does pretty much the entire.
So you should find it.
That's
good,
very
that's
nice. Well, I would be creating these things, and I'm like, why
No,
aren't
we
they
gotta go
using
back.
these? Why don't I see them? Well, now I know why. Because obviously someone has made some graphic infographics. Because if you're under the age of 18, you do not get infographics in Notebook LM.
Yep.
Oh.
So what we need you to do,
Wait,
What?
why?
I guess somebody's made graphic infographics. I don't know.
Why is it why would I about your age?
Oh, I see what you're saying.
This is it's part of the program. In other words, Notebook LM does not allow infographics to be distributed to minors.
They're dangerous. I wonder why.
I'm sure this is something I can't change.
I wonder why.
I'm sure somebody could have used that to send terrible things to people. But for Lesniak AI, which is just a chemistry class, there's no graphic infographics that can be made. So therefore,
This
in
YouTube
order to
channel
get
just got
these,
PG-13.
in order to get these very nice and useful tools,
This might
please
be age restricted.
invite one of your parents
Yeah,
to
this one's gonna have to be not for kids.
send a permission to get access to Notebook LM. Then you will have these at your handy dandiness. Now,
Handy dandies.
I actually want to say
everyone has access now to Notebook LM.
I really want to learn his YouTube channel.
Yeah.
Me. How?
I'm gonna be age restricted.
The links will be at the top of all of your lesson plans like they were this week. So, again, if you have a parent, just go ahead and email me. They'll get permission to get into the Notebook LM, and then they will easily be able to go through some of these infographics I've created. Created with the help of AI. Yes.
Thumbnail, it's just
I just had one idea.
Lesniak's
What if
reviewing or something.
would it be possible for you to create like a Google Drive folder and just put these resources in there?
We can definitely look. We can definitely download, and you can actually do that at home. But here's the thing. Yeah, we can make it. You would have to still access them and do these things. If we get to ones that are like vital, like the airplane, I'm just gonna print them out and give them to you. Right? But there's nothing that's on this that's not in your notebook. This just puts it for some people in a visual way, and some people are visual learners, and this would be very helpful. Like, there's a couple things I would have done differently. That if you just put like this and don't have units in these, but I'm taking points off, right? So, you just make sure. Now, this one actually has units for degrees Celsius, but doesn't have the joules down there. So those graphs are close to hundreds, but they're not 100s. I do like these though, and the golden rule, because this is what we used here in a closed system, the heat lost by a substance equals the heat gained by water, or whatever the reaction is. And so this is how, we're gonna double check this because I need to make sure this is right. This is how this problem was done. So, on this side, I'm going to walk through that problem. So we know that the heat gained by water, the only way for that temperature of the water to go up was the heat lost by the rock going down, by our unknown rock. That is kind of the golden rule. And so now we can use our data and the information that we know to actually calculate this, okay? For instance, so in other words, the Q gained equals the Q lost. And we can solve for Q. especially for the water, because we know all the things we need to know. And once we solve for Q for water, and we have, look at that, it's beautiful. We have our formula. What was the mass of water again? 55.0 grams. The C for water is memorized in your brains.
Oh. Then it changed by 7.0 degrees Celsius.
And it moved up by 7.0 degrees Celsius. That is the Q. We plug this into our calculator. We do have to use 2 significant digits. And our answer is? What is the answer?
1,600.
And give me the, real quick, I just want to, and do notice that degrees Celsius and grams cancel. So we're in a great shape. This is our Q gain. What is the actual number without rounding?
I keep, hold on, let me get my calculator.
Make sure we have our calculators out and ready to do calculations. Yes, Briella. Is it necessary? I guess so. All right. Definitely want to go back down to minute what? What minute were we at?
16.
We're at minute 16.
It was 16:10.
16:10, so it's darn close.
16.
I like it. All right, so now we can actually start solving for the C of this, because we have everything we need. Now I'm just taking the same formula and I'm solving it for C, because we now know that C, this is what you actually have in your notes too. You have both formulas in your notes, is equal to the energy, mass, times delta T. And now we have all of those from our lab, which is great. We have the Q, we just calculated, 1,600 joules. We have the mass of our rock. What was that mass again?
The mass of the rock.
We have, like,
Yeah.
Jack and I are having a really good class.
Sorry. Yeah.
You have, all of you have this data. I understand it's Wednesday and you had a day off yesterday. We're not engaged yet. Engage, class. All of this data is in your notes.
Monday all over
I
again.
need a solid boot.
Ugh.
Oh, we do.
All right, the mass of the rock was what again?
26.8 grams.
Did you say my name?
26.85 was the final.
That's right. 26.85 was our final
Holy
resting
schizophrenia.
place. Well done. And it went down in temperature from 100, because we had it in that boiling water, all the way down to the 27. So that's a difference of
2.
72.
went to 27.
Ah,
You did?
We all knew
28.
that.
You're right. It went up 7. You're correct.
We all knew that.
0.0 degrees C. It is going to end up in 2 significant digits. And this is, hopefully, everyone should put this in their calculators and get 0.83. 1,600 divided by 26.8 divided by 72. And again, if you're going to multiply these two things in the bottom, make sure they're in parentheses in your calculator, or your calculator will just divide by this, then multiply by that, and you'll get a wrong answer. Because your calculator does follow order of operations. You want to divide by this entire denominator. So make sure it's in. Or you can always just hit the divide button if it's on the bottom. And we got?
4.
We get 0.83.
I got that.
That's good. So we have,
I got 0.8.
Yeah, that is it.
What's the answer?
That's the answer.
0 points of right answer.
0.83 is what it is.
Yeah.
Oh.
so look, our data and observation section is going to have all of this data. You can put it in chart. Listen up. I'm trying to get you a really good lab grade. You can put it in chart form. All right. You can just make a chart, mass of rock, this, energy loss, final temperature, beginning temperature. You have all the data. Everyone has the data. How you organize your data and observation, make sure you report that data, number one. And then number two, make sure we have our calculations. And at the end of your data and observation, this is your data and observation, and you should show me how you got to these points. All right? It should not be that difficult. But I should see some differences in how you guys want to organize them. Why? Because you're different people. Some people like charts. Some people are going to just list things out in bullet points. Some people will do different things. Some people use different colored pens for the different measurements. I do see some good stuff when it comes to how you guys write your own things. And then finally, we get to our conclusion. We know the first thing that has to take place. All right? We can't do a percent error for this one. Why can't we do a percent error for this one? Let's see if
Can't live on something. Didn't make a mistake.
who thinks they can get why they can't do a percent error? Just throw out some ideas. Use our brains.
Can't blame on the calculator.
No.
Syntax error?
This one is, I'm not saying it's impossible, but there's a really obvious reason why we can't do it. Yes?
Because we can't predict the result.
No?
Jack got it wrong.
There's no percent.
No? How about this? I'll ask this. What do you need to have in order to do a percent error or a theoretical yield? What do you have to have?
Reasons.
I don't mind that. You actually have to have an answer. You actually have to know a standard. Look, do we actually know what this rock is?
No.
No, so we don't even know if these are, the reason we don't know these are right is because we don't know what this rock is. We're gonna use these to do our best to identify a rock.
Kind of right.
So yes, if we knew what this was,
Then you can do it there.
then there would be something to compare these measurements to. But we don't know what this is. We're hoping that these are good enough. We're hoping that our lab procedures, and we followed things as successfully as possible, did multiple trials. We're hoping that these are close enough for us to have a really good guess at what this rock is. And I have it down to 2 things. So I'll see what you guys can do. Because if you actually do an identification, and your identification makes some sense based on this data, I said I would give you extra points. All right, so your conclusion, it must come back to the purpose. We must come back to this idea of using both density and calorimetry to find out the identity of a rock. And you should be able to explain, yes, we measured the rock's density, we measured the rock's specific heat capacity using calorimetry, and now we have an opportunity to identify this rock based on these physical characteristics. And I believe the rock is, and hopefully you get, because we know what it's not.
Cotton.
We know it's not magnetite, at least in pure form. Because if it were pure form magnetite, 1, it would look different. It would not look like this. And 2, it would have a different density. We know that it has a density around 6. And I don't have the specific heat capacity of magnetite right off my brain, but that could be easily looked up for sure. Actually, I did look it up. It's charted based on the temperature in Kelvin. So, but
Yeah, I could tell you on this
0.83, I'm kind of liking it. All right, so I'm bound to see, and remember in your conclusions, the more, I'm not saying the more words you use, the more it sounds like you understand the chemistry, the better your points are. It's that simple. And I'm hoping you guys understand this chemistry. I'm about to find out. All right, you can now shut that off because we're done lab discussion.